Hello and welcome to another video of time series forecasting. In this video, I'm going to talk about how to evaluate a regression model. And again, we are going to base our evaluation of the fitted model based on our predictions and our observed or actual values. So remember, every time we fit a model, we'll have two values, the fitted values and the actual values. So let's call our predicted values as y at time t hat and our observed or actual values as y at time t. And the difference between the observed and the corresponding fitted values is called a residual, and we normally represent a residual as the difference between the actual values and the fitted values. So please note that sometimes I'm using this epsilon letter and sometimes ut to represent the residuals, but if you pay attention to the concept rather than the symbol, you should be fine. So we can represent this as the difference between yt, and our model may be a multiple linear regression model, and we will have these estimated coefficient values. Okay, so we can calculate our residuals based on this difference. So as we did previously, we will analyze the properties of these residuals to evaluate our regression model. So what we can do is we can look at the ACF, and remember, an autocorrelation function or ACF plot shows you autocorrelation among various lags in a series. So if we plot these residuals on an ACF, it will show us autocorrelation among the residuals. Normally we want no autocorrelation among these residuals, and if there is some autocorrelation here in the residuals, it means we left over some of the information that should have been used to predict the model. In other words, we can improve our forecast by tweaking our model a little bit by using all the information which is available. Hence we want no autocorrelation in these residuals. And similar to the long box test that we used earlier, for the regression model we use Brouwer-Godfrey or LM test to know whether a series is showing us autocorrelation or not. And the null hypothesis for this test is the absence of autocorrelation in the residuals. And if the p-value is small, it implies that there is no serial correlation in these residuals. And then we can look at the histogram of these residuals to check whether these residuals are normally distributed or not. We don't have to do everything individually. All these functions are packaged in the check residual function in R. All you have to do is pass your fitted model in here, and you will get an ACF plot, the Brouwer-Godfrey test, and the histogram. Alright, so this is how you evaluate a regression model based on the difference between the actual values and the fitted values. That is, you analyze the properties of the residuals, and we want no serial correlation in these residuals, and we look at the ACF plot, or we use Brouwer-Godfrey test, which is the regression model version of the long box test, and we test for the serial correlation in the data. And if we get a large p-value of this Brouwer-Godfrey test, we conclude that there is no serial correlation and our model is taking advantage of all the information which is available. On the other hand, if our Brouwer-Godfrey test reveals that there is serial correlation, we need to go back and look at our model because we are leaving some information that should have been used to predict the model. Alright, I'll see you in the next video to show you an example in R to evaluate a regression model. Bye bye.